All right, let's get started. So, how many calories in 3/4 cup?
240 calories.
He wants 240. Agree?
Yes.
1 point. All or nothing. Okay, what kind of reasoning? If 2 cups is 8 times as much as 1/4, to get the number of calories, we got to take 8 times as much as 80. What's the key? What's the type of reasoning that is? Scaling factor. As long as you have the word scaling, that's the key. Scaling factor reasoning. What's the scaling factor in that case?
8.
He said 8. Agree? We're scaling them both up by 8 times. 1 point. For scaling or scaling factor. What number multiplied by the number of cups gives you the number of calories? So what do I need to multiply the cups by? Any amount of cups to get the number of calories.
320.
He wants 320. That's it. 320. 1 point. All.
Is that like referring to natural limit?
If you have the number of cups, what would you have to multiply by to get the number of calories? 320. So 320 times 1/4 is 80. So how would you find that number? If, say, if those were ugly numbers, like ugly decimals, what would you do to get that multiplier? Yeah.
Well, we already figured that out, that 3/4 says 240.
But if it was like 0.36 cups has 98.2 calories, how would you get that multiplier? Okay?
98 divided.
It would just be your number of calories divided by the number of cups, right? You would just take your final number and divide it by, which I think is what you were saying, divide it by your number of cups, and that would give you what you would need to multiply 1/4 or 2 cups by to get the calories. In this case, it's 320. 1 point. Okay, what is that thing? What is the multiplier that takes you from one quantity to the corresponding amount of the other quantity?
Or the common multiple?
He said constant multiple. That's what it is. Constant multiple. 1 point.
Yeah, that's what I did too.
It's really, the whole point is no matter how many cups we have, it's constant. It stays constant. That multiplier stays constant. So it's a constant multiple. We need to change common ratio to constant ratios, and then it's always constant, okay?
Yeah.
But yeah, constant multiple. All right. So we want to write B in terms of A. That means B equals something with A's. Meaning, how would I get the number of cups of oatmeal given the number of calories?
8 divided by 320.
Yeah, so it'd either be A divided by 320 or 1/320th A. Either one of those. How many points have we got? 5? We have 5 points? Okay, so remember, this is much more about the learning experience. The grading is the learning experience, right? We're figuring out what we understand, what we don't, and getting our understanding more towards good thinking, okay? So that's what this is about. Uh-oh. Okay, everyone good so far? Can I erase? Here we go. Problem 2. V equals, so want to define this well.
The volume of water after the faucet was turned on in cubic inches.
Okay? So yeah, so it's something like that. So you want the volume of water in the sink, and then make sure there's some kind of units. So I didn't say, so in centimeters cubed, inches cubed, oh no, gallons. It's gallons, right? Gallons, sorry, in gallons.
If we forgot that one.
Yeah, so this is worth 2 points, and I'm going to leave it up to you to determine if you get 0, 1, or 2 points on this. You got to have the unit gallons, and it's got to be volume of water in the sink. That's a changing quantity, right? Because as it fills up, the volume's changing. So 0, 1, or 2 points. It's worth 2. I'll just leave it to your discretion to give yourself the right amount of credit. Okay? T is? Okay, yep, that's good. He said time the faucet's been running since the beginning in what? Minutes. Okay, or you could say time elapsed since the faucet was turned on. That's good too. In minutes, again, 2 points. So 0, 1, or 2. Got to have the units. It's got to be this changing quantity. You got to have this since the faucet was turned on, something like that, or since the water started running, something like that. Okay, so that's worth 2 points each. All right, building a table. So at 0, how much volume? 1. Tried to give you a nice easy one. 2. And finally, those are the easiest 4 pairs you could do. But if you had other pairs, as long as what? Look, the volume is always what related to the time?
2 more.
Adding to quantity 2. So as long as your pair, you have a pair where V is 2 more than T, that's a valid pair. You need 4 of them. Okay? Let's make that worth 2 points as well. So yeah.
For A, was it 2 points for V and T?
Yeah, so A is worth 4 points total.
Okay.
0, 1, or 2 for your volume definition, 0, 1, or 2 for your time definition. And this whole table is worth 2, okay? So if you got 4 good points, you get 2. If you messed up a little bit, you get 1. If you have nothing like this, you get 0. Okay, are they proportional? No. How do you, so that's the first point? No. How do you show this with, we're going to start calling it constant ratio reasoning, okay? So it's always the word constant. Constant ratio. How do you show this with constant ratio? How do you show that they're not proportional with constant ratio?
I said after 3 minutes you have 5 gallons, and if you wanted to see how many you had after 6 minutes, you have to multiply by 2 on each side.
That's not constant ratio. Constant ratio is where we take T over V. This is what you have to show. You're setting up ratios of the ordered pairs. And you're saying if it's proportional, then what would these ratios be? They'd all be equal. But the 3/5 is not equal to 2/4, is not equal to 1/3. So since the ratios are not equal, it's not proportional.
So if we just said the ratio does not stay constant, do we have to actually show?
Yeah, you got to show what ratio you're talking about. Yeah. So let's make that second part 2. So that would be 1 point. Okay? So you really got to show exactly what ratio you're talking about. The ratio of T to V does not stay equal. If the ratios are not equal, these are not proportional. So D will be worth 3 points total. 1 for no, 2 for your showing this reasoning. Yes, sir?
What do we have 2 ratios?
Oh, yeah, that's all you need. All you need to show at one time that they're not equal. Yeah, I kept going. You don't need that. As soon as one ratio is not equal to another one, you're done. It's not proportional.
So what if we explained it, we just didn't have the numbers?
I can't answer all the questions. Just give yourself. Just go. So this is
3
worth
points?
1 point for no. This is worth 2. So either you just totally missed the boat at 0. You kind of had something 1. If you have exactly this kind of explanation, that's worth 2. Okay. So we got 3, 5, 9. I think it's 14 points. Is that right? Is that right? 14 total points. Yeah.
I have a question.
Yeah.
It goes back to number 1.
Okay.
On B, I put B equals A over 80 times 1/4 instead of A over 3.
As long as the formula is the same as what I had. Like, look, give you the same thing in the end?
Yeah, it's the same answer.
Yeah, it's okay. Okay, so what you want to do, take your score out of 14, add 6 points. Just add 6 points, and then we'll make it out of 20, okay? Thank you, you're welcome. So add 6 points, and then take that new total out of 20. Any questions about, not grading, I don't want to answer everyone's individual questions about grading, but about the principles or the mathematics. Questions about the principles or mathematics on this quiz? Okay, so your answer's out of 20. Answer's out of 20. Flip it over. Pass it in. So go ahead and open up to, we're going to move on to worksheet 3. And what I want you to do is just get yourself familiar with that scenario, that context in Module 2, Worksheet 3, right at the beginning. What page is that? Page 27. So get yourself familiar with what the context is. You can start working on page 27, and then I'll just go as far as you can, and then we're going to kind of do this a little bit together. So. Okay, everyone read it? So we're talking about changing the size of a photo, starting with a 6 by 10, and we want to enlarge it or shrink it so that the photo is not distorted. Okay? Okay, so let's take a look at this. So here it's saying h is always the same multiple of w. So the height, 6, is always 6/10 of w, which is 10. So if we want to know the height for a 25-inch photo, is that the question? What question is that?
First.
Is that question A? So if we wanted to know the height for a 25 width photo, we should multiply that width by 6/10 to get the new height. What kind of reasoning is that? Is it scaling factor, constant multiple, or constant ratio? Scaling factor. Is it scaling factor?
No, constant.
He says no constant multiple. We got to make sure we know the difference. Which one is it?
It should be constant.
So are we scale? So scale. This is scaling factor. You take one of the quantities, say the width, and you scale the width to a new dimension, and therefore you got to take the height and scale it the same way. Is that what we're doing here?
No. You took the height and you found out what it is compared to the width, So that would be a constant multiple between any height or any width.
Yep. Did you hear what he said? He said, say it again.
I said that you took the height and you compared it to the original width,
That's right.
so that you have the constant multiple that can then be used in any height or width.
See, look, we're taking, is 25 a width or a height? A width. We're multiplying it by this number 6/10, and we're getting what? Height. Is that scaling factor or constant multiple? It's constant multiple. Constant multiple is the number that if you multiply one quantity by, it gives you the corresponding value of the other quantity. This is constant multiple. What is the constant multiple? 6/10. If you had a 100-inch wide photo, how would you get the corresponding height? Multiply it by 6/10. You have a 3-inch wide photo. How would you get the corresponding height? It's always 6/10. Constant multiple. Constant multiple takes you from one quantity to the corresponding value of the other quantity. Okay? W2, 25 inches for the width is 25/10 as long as our original width, 10. So our height needs to be 25/10 of the original height of 6. So the new width, starting with the old width of 6, is 25/10 as much as the old width. We better get this one right. This is scaling factor or constant multiple? Scaling, you see? We're saying, here's the original width. What do we need to scale it up to get this new width? We got to do the same thing to the height. That's scaling. Questions on that? Doesn't make sense. Constant multiple is the number that if you have the one quantity, you multiply it to get the other quantity. Scaling factor is we start with one quantity and we change that quantity. Like we say we want to magnify it by 4 or shrink it by 3. And if we do that, then we go to the other quantity. We have to do that same scaling effect on the other one.
So when you're saying it's scaling, you're multiplying it by 25 over 10. You're multiplying 6 by 25 over 10. That's pretty much the same as what you did before. You're multiplying by something you're not.
No.
That's what it seems like.
Is 6 a width or a height? Wait, so okay. You're confusing me.
Sorry.
It's okay. No, let's get it. It's important.
The 6 is actually a height.
Here's,
I'm confused about the differences. I'm just saying in that example right up on the board.
this is
the one
6,
on the right
this
is
is
definitely
10.
multiplying, but the one on the right is multiplying as well.
Oh no, so this is H. And this is W. Original photo, right? And the new photo is, we know what dimension do we know for the new photo? 25 for the width. Okay, and then so we're saying, what's the height? So constant multiple says this. What do I need to multiply the width by to get the height in any photo? What do I need to multiply by? 6/10. That's constant multiple. So therefore, to get the width on this one, I'm going to take 25 and do what? Multiply by 6/10. And that'll give, that's exactly what this is saying here.
Gives you 20, correct?
Is that good so far? Okay, now scaling factor. Let's see if I can just erase just the parts we want here. Scaling factor is like this. Scaling factor says, I've got the old width and the new width. What do I need to multiply 10 by to get the new width? See how different this is? What do I need to multiply by to scale up the width from 10 to 25? 25/10, right? 2.5. So therefore, what do I need to do the old height to get to the new height? multiply it by 25 tenths. Is that what it does on the right side? Yeah, it works. So that's what they're doing here. But this should have been height, right? Is that right?
Yeah.
That's the problem. This should be height 2. Thank you. That should say height 2. So yes, you were right to be confused.
I think. Did they screw up on the other side too? Shouldn't it be width too?
Nope.
No.
No, because you're
On the left hand side.
It's only this one. All right. Does that clear it up? Is that better?
Oh, he does.
Okay. Last chance. Good conversation. Got to make sure we get this. Okay. Have we been consistent? I think we have. Okay. So here's a table with, and given the width, it's saying that the height is always 3/5 times the width to get the height. Constant multiple or scaling factor reasoning? What is this showing? Constant multiple or scaling factor? Constant multiple. It's the number you multiply one quantity by to get the other. Okay? So starting with 10 and 6. 1/10 of 10 is 1. Therefore, to get the new height, you take 1/10 of 6. Or, to get from 10 to 25, multiply by 5 halves. Therefore, 6 to get 15, multiply by 5 halves. What kind of reasoning? Here's scaling. We're scaling up one quantity, need to scale up the other one likewise. Anybody have a question? Okay. So, I got to do this. Okay, showing different photos, okay? Width, height. So, with a graph, represent this pair of measurements on a graph. So we're kind of doing this together. Part C. So we can put the width on the horizontal axis, the height being the vertical axis. So we find that width on the horizontal axis, and then that height on the vertical axis, and that gives us a point. So this point on this graph, what does it represent? What does that point on the graph represent? Nope. In the whole scenario, the context of the problem, what does that point right there, what does it represent? Point.
Constant.
No. What's that? The picture. Which picture? Yeah, so whatever this picture is that has a width we call W1 and a height we call H1, that point right there represents that photo or that pair of coordinates, that pair of quantities. The width quantity and the height quantity taken together is represented by that point. Okay, so if we want a larger photo, so W2, a larger photo, we get the corresponding H2. How is it going to be represented on the graph? What's that?
It's going to be farther down the width and higher.
What will be further down?
The point.
The point. So now we go to width 2 as the x-coordinate, or the horizontal coordinate, H2 as the vertical, gives us a new point. So that gray point now represents the larger photo. So we can do this many times. Oh, shoot. So every point represents a photo. Take all the points, and what do you get? All the points together? Yeah. So this, when you see a graph like this, a line, really your image of it should be what? Why did it do that? Oh. Perfect. Okay. So every photo is a point, and if we take every single photo and graph every single point, we don't want to sit here and draw dots, right? So we have the easier version of drawing that, which is the line. So your image of a graph, it's not like a stick or a wire that you move and bend. What is the graph really representing?
Points.
Points, a collection of points. A collection of points. How many points? Yeah, an infinite number, right? So there's an infinite number of photos that we could pick, all these different sizes. So a graph, this is really important. It's not a stick, it's not a wire, it's a set of points. Each point has meaning. In this case, each point represents what? A photo. The information about a photo, both the width and the height taken together. Okay. All right, so what I want you to do is go to 2A. Now 2A, in order to do all the work you would need for 2A, they should have given you a half a blank page. There's a lot going on in 2A. So read 2, slowly and carefully, read 2A, and you can use, just kind of ignore B for now, use all that space below A to answer A, because there's a lot of stuff going on. All right? So this is really important. We're kind of moving on to the next thing. Just doing 2A only. But there's a lot of work there. Work together. If you don't have your book, look over someone's shoulder. Or just look on the screen. There we go. There it is. Everyone's working on it. On the screen. Got a question, I can answer it. Compare with the person next to you, work together. What kind of reasoning did I use to find these heights? What's that? Did I scale? So I found height 1 by taking my 3-inch width and multiplying it by 3/5. Scaling factor or constant multiple? Taking the width, multiplying by 3/5 to get the height. Constant multiple. That's the same as 6/10. 3/5 is the same as our 6/10. Constant multiple is the number you multiply one quantity by to get the other. To get the other. That's what I'm doing. I'm taking the width, multiplying it by 3/5 or 6/10 to get the height.
How did he get the 3/5?
6/10 from our earlier problem. Remember we said the height is always 6/10 of the width. So I just reduced or simplified the fraction to 3/5. Same thing, I took the width of 4, multiplied by 3/5 to get. Yeah, you didn't have to do it that way.
Yeah, we did 3 tenths. We scaled down. We had like 10 and multiplied by, or we had 6 and then multiplied by 3 tenths because scaling down. That works.
But they're asking about the height of a 3-inch photo and the height of, in the end, maybe that's okay, but in the end they want the height of a 3-inch and the height of a 4-inch.
We got 1.8 and 2.4. Yeah.
That's the same, then you did okay.
So that's fine.
Yeah, they're interested in the height of a 3-inch and the height of a 4-inch. And now what they're asking for is this is a new quantity now. This new quantity that they're introducing is actually a change in height. Delta is the symbol for a change in a quantity. Okay? So it's different than the height. The height is how tall the photo is. A change in height is, we got one photo, how much did we change the height to get a new photo? That's a different quantity. So this change in height is how much? 3/5. And that came from a change in width, so our change in height here was 3/5. Came from a change in height of what?
1.
We went from 3 inches to 4 inches. Change in width was 1. Okay? And then they asked for the same thing again. They want they're talking about a 7-inch wide photo. How can I find the height of a 7-inch wide photo?
6/10.
By 3/5, which gives me? All right, what's the change in height for these two? How many fifths? 9/5? Are you tracking with me? So from this photo, the 4-inch wide photo to the 7-inch wide, the change in height was the change from 12/5 to 21/5, which is 9/5. What was the change in width for that one? How much did the width change?
They're 3 inches.
3.
Didn't it ask for the, yeah.
Oh, no.
3-inch,
Oh, shoot.
But just, it makes sense still.
It'd be 12 fifths.
Okay, so sorry, I got off track. So, but it's the same. The end point is the same. So I did the change from 4 to 7 rather than 3 to 7. Okay, so the question is, let's take a look at comparing change in width to change in height. Don't tune out on me. So when the change of width was 1, how much was the change in height? That was that first one I did up here. When the change in width was 3, how much was the change in height? Some of you did the actually what they asked for. When the change in width is 4, how much is the change in height? 12/5. Do you see a relationship between these new quantities, the change in width and the change in height? What relationship is it? is there a number that I can multiply the change in width by to always get the change in height?
Yes.
What is it?
3/5.
It's the same one as for the height and the width. This is a big conclusion here. So our constant multiple to get us the height from the width was 3/5. If you look at pairs of changing width and changing height, those are also proportional, and they have the same constant multiple. This is a huge, really important thing.
Is it okay if we make them decimals?
It's harder to see. It's harder to see this conclusion. It's okay, but it's harder to see what the point we're trying to make, which is that if two quantities are, listen up, if two quantities are proportional, then the changes in the quantities are also proportional, but more than that, with the same constant of proportionality. So that ends up being having the same proportionality constant as our original quantity.
So if something is proportional,
Like height and width are proportional. And now change in width and change in height are also proportional with the same constant. We're going to get there. Okay, so you have the first major assignment. I'm not going to see you until Wednesday. Have a nice Labor Day. But the first major assignment due Wednesday. Separate notebook paper. Yeah, it's on the blackboard.
Okay.
And on blackboard, you'll see assignments.
And then, so should I just go back and do all the assignments that are listed up on Wednesday and then just show you those?